So let's continue on with our properties of rational exponents. So now let's work with negative exponents. So remember, with negative exponents, we're going to move what's connected to that negative exponent to the other side of the fraction bar. Okay, so if it's at the top, it'll go to the bottom. If it's at the bottom, it'll go to the top. So what's most important is you only move what it's attached to. So with 19, there's only the 4 to the negative 2. So there's nothing that we need to separate. So we could rewrite this is 1 over 4 squared. Okay, and so the only ones we're going to move will be like our negative 5 here, and then our 27 to the negative 1/3. 24 may be a little bit challenging, but see what you can do. Try these out. So pause the video and try these out. All right, if you tried it out, number 19 was 1 over 4 squared, which we did previously, so that's 1 over 16. We could simplify that a little bit more. And then for 21, the only one that moves is the x to the negative 5th power. So the square is positive, so it stays where it is. The negative 5 needs to move. So the x to the 5th goes to the denominator. And then we could simplify. So 3 squared is 9, so 9 over x to the 5th. Number 22, so with the negative exponent, I'm just going to move that 27 to the negative 1/3 to the denominator. The x squared stays at the top because, again, it's positive. It's a positive exponent, so it stays where it is. And so we could rewrite that, and I'm sorry, this is a square. So if 27 to the 1/3, we can rewrite that as an nth root. It's really cubed root of 27. And the cubed root of 27 is 3. So you can simplify that a little bit more here. So we'll clean this up a little bit. 2 and 2. And then the last one, so this one was a little bit more challenging, but just had to go in steps. And there's lots of ways you could solve it. So this is just one way. So remember, this is the same base. So that means we can add the exponents. So we can do 3 to the 6 plus 3, which is 9. 3 to the 9th. Then we still have the negative 1/3 out here. So remember, we can multiply that. 9 times negative 1/3. So I just went ahead and multiplied that. So that becomes 3 to the negative 9/3. And I know that I can simplify that. 3 goes into 9 3 times. Now it's still negative because there's a negative here. And then it's kind of similar to number 19. So if it's 3 to the negative 1/3, we can rewrite it as 1 over 3 cubed. So again, when it moves, then becomes a positive exponent. Then 3 cubed is 27. So 0 exponent, try these examples out. So remember, anything raised to the 0 power is 1, but you need to be careful. Okay, so anything raised to the 0 power is 1, that you do some operations. You might need some parentheses as a hint, just to give you a hint. Number 29 is not 1, and number 32 is also not 1. Okay, so those will be a little tricky. Pause the video and try these out. So the first example is 1. 5 to the 0 is 1. That 0 is attached to that 5 there, so it's 1. 45 to the 0 power is also 1. Now 29, you have to be careful. The exponent of 8 is actually 1, right? It's not 0. The 8 still stays. But x to the 0 does change. So you could rewrite it as 8 times x to the 0. So the x to the 0 is the one that changes, and that's the one that becomes 1. So then our final answer is 8. Then number 32, that's pretty similar as well. So x to the 0 is 1, and y to the 0 is 1. So you actually have 12 plus 1 over 1. And 12 plus 1 is 13, and we don't need the 1 in the denominator. Let's look at quotient of powers. So remember, with quotient of powers, so when we're dividing, we're going to subtract the exponents. Dividing, we subtract the exponent. So remember, if there's nothing there, there's an invisible 1. So try out these 4 examples. Now remember, if there is no exponent that you see, that is always 1. So try these out. So number 38 may be a little bit challenging, but see if you can try to figure it out. All right. So for number 33, 2 to the 7 over 2 to the 1, you're just subtracting the exponents. So 7 minus 1 is 6. So it's 2 to the 6th power. 36, so we're going to subtract. So a, keep the bases the same, a, and then 8 minus 2. So that is 8 minus 2 is 6. Then b to the 5th over b. So we're just going to subtract a 1 because that's b to the 1st power if nothing's there. And then so 5 minus 1 is 4. So it's a to the 6th, b to the 4th. Number 37, we have 4 to the 5 halves and 4 to the 1 half. So don't let the fraction scare you. You're still going to do the same thing. You're still subtracting the exponents. So we have 4 raised to the 5 halves minus a half. So 5 minus 1, so it's a common denominator, so that's nice. 5 minus 1 is 4 in the denominator of 2. And remember, 4 over 2 is just 2. And then we could simplify it, right? 4 squared is 16. Number 38, so that one might have been a little tricky. So there is an invisible 1 here. We're still subtracting. So this is 5 to the first power minus a third, right? So again, it doesn't change. It's still the same, 1 minus 1/3. And so you just have to get a common denominator, right? You're not allowed to add or subtract without getting a common denominator. So what I did is I multiplied the first value by 3 over 3. So now I have a common denominator of 3. So notice it's here. 1 times 3 over 3 is just 3 over 3, so that stays. So we have 3 over 3 minus 1/3. So 3 minus 1 is 2 over 3, and now we are done. Last examples. Power of a quotient. So we need to make sure that we simplify as much as we can. So see if you can try these out, okay? So these are a little bit challenging. So number 43 may be a little bit more challenging. But remember, what does 1/3 mean? How could you rewrite that? Now 44, notice they have the same exponent. So as a hint, we can use the property that we had earlier on. If we have the same exponent, we could simplify it a little bit. So again, try these out. Pause the video. All right. So we distribute this 3 to both the top and the bottom. So it's 4 cubed over 7 cubed. And we can leave it as it is, and that's fine. We have 1 over 5 raised to the 7th power, so we can distribute it. So 1 to the 7 over 5 to the 7. We can simplify this just a little bit. 1 to the 7th is just 1. Number 43. So what you want to do with this one is we can distribute it to every term. So just like we did with number 39. So we have 27 to the 1/3 and 64 to the 1/3. And remember, it's just an nth root. We can rewrite it. Cubed root of 27 and cubed root of 64. So again, the denominator is our nth root. So cubed root of 27, that's perfect. We can have it's a 3. Cubed root of 64 is 4. So our final answer is 3 over 4. Number 44, so that one's a little tricky. But if you notice that it has the same exponent, so what we can do is we're using that distributive property, and we're just going to push it to the outside, right? It's just kind of like we have the 1/3 here, we distribute it in. Notice we could take it out and put it all on the outside. That's really what's happening here. So we're going to go the other direction with that. We're going to take this 1/3, and because it's the same, we're going to put it on the outside, just like this is on the outside. So just notice the relationship here. So it's the same, we can push it out. Now with this step, you can divide the 42 and 6. So 42 divided by 6, or 42 over 6, is 7. And then that 1/3 is on the outside. But remember, it's power to power, so they're going to multiply. So it's going to be 1/3 times 2, which is 2/3. So the final answer is 7 2/3. So just to wrap it up, the key ideas to all of this is knowing the basics of the properties of rational exponents. Again, when you're multiplying with the same base, you're going to add the exponents. When you have a power to a power, you're going to multiply the exponents. Now here, power of a product, you make sure you distribute to everything inside. Negative exponent, you move it to the other side of the fraction bar. Anything raised to the 0 is 1. When you have a to the m over a to the n, so that's dividing, we subtract the exponents. And then last, we can do a to the m over b to the m for power of a quotient. And remember, it can go both directions.